Hey guys, today's screencast is going to be divided into two parts. The first part is going to be an analysis of global water resources and a re examination of our water cycle. And the second screencast to follow will include an analysis of groundwater supplies, which are critical for both irrigation and human consumption. And so we'll break groundwater down in terms of its structural components and anatomy. So let's start with global water resources, which is a fascinating subject to take a look at. When you look at this map, I think it really exemplifies what's going on in the world. And what that shows is that really there's a huge disconnect between countries that have an abundance of water resources and those countries that do not have an abundance of water resources. So it's sort of a hydrologically divided world into the haves and have-nots. A classic example would be to look at the country of Canada, which we know has about 0.5% of the global population, yet it contains 20% of the global water resources. So climate clearly here is influencing which locations are experiencing lots of precipitation, and our neighbors to the north get ample supplies of it. Compare that to a country like China, on the other hand, which we know has about 21% of the global population, yet only has about 7% of the global water resources. So it's really interesting to see those disconnects. Anyways, if we take a look at the Middle East, this is sort of the hotbed of obviously a lot of political instability and a lot of wars fought over, for many reasons, civil unrest, cultural and religious ideologies, make this a place of great political instability. And a lot of these wars are, many could argue, are fought over a precious resource that we know to be non-renewable resources such as petroleum and oil and natural gases and so forth. And that's interesting, but many analysts suggest that, okay, well, we're fighting these wars today because of fossil fuels, but guess why these wars are going to be fought in the future? Not necessarily over petroleum, but probably over water resources. When you look at the world, the Middle East has the highest per capita average of people that lack access to an abundance of water resources. And so as a result, there's already political strife and instability because people are looking for ways to access more water. You only have to think of the Nile River. Well, we know Egypt is at the end of a long line of countries that utilize the Nile River for diversions that can be used to feed people through irrigation and consumption. So, of course, Egypt is unfortunately at the end of a line where Ethiopia and Sudan are going to be using a lot of those resources and therefore diverting much of those water resources before they even end up in Egypt. So that creates political tensions. The Jordan River Basin, probably even a more dramatic example of this, where you have countries such as, Syria, um, Israel, and Jordan, who are all vying for the same water resources. And when one country starts damming those resources and the water isn't going to be trickling into their country, that is going to lead to some serious conflict. Another great example is, of course, the Tigris and Euphrates River, which originates, of course, with the headwaters in Turkey and then spills out into the Persian Gulf. So many countries residing in these locations, including Iraq, Syria, and Turkey, all of which are vying for the same water resources. These are going to pose significant problems in the future. Many of these countries in the Middle East, however, are working on sort of technological fixes to this issue. Yes, they have an abundance of fossil fuels, and so they're making use of those fossil fuels, by creating massive desalination plants. That is, technological fixes in which we can remove the salt from seawater. So this is a very high energy intensive process, of course, and very expensive, but since many of these countries have ample supplies of petroleum, they are capable of doing this. But of course, it is extremely costly. So let's take stock real quick and examine the water resources that we have here on planet Earth. It's really interesting if you were to think about or make an analogy and try to think, because it's difficult to sort of get an idea of how much water there is on planet Earth. If you were to boil it down to, let's say, 26 gallons of water that we have on planet Earth, of that 26 gallons, about 2.5 tablespoons would be actually available to us as fresh water. Wow, so that's amazing, and of course that makes sense. We know the majority of our water is found in our oceans and perhaps saline or saltwater lakes. So you can see 97.4%. So that doesn't leave much in the way of fresh water, but of course even that 2.6% isn't accessible to humans. Much of it is not, right? Because the majority of that fresh water is already locked up in ice caps and glaciers. Also, a significant portion of it is also found beneath our feet in what we call groundwater. And some of that is just too deep for us to access economically. Finally, we do have some surface water, we know, that can be found in lakes and streams, and some of that we can utilize. And so ultimately it leaves about 0.014 to 0.024% that is accessible to humans. So it's not much, but yet we know that water is a renewable resource, and that's a very good thing. We only have to think of course, the water cycle. We know this well. The water cycle is driven, of course, by the sun. The sun heats the ocean, causing water to evaporate, and that water vapor enters the atmosphere where it rises, expands, cools, condenses, and forming clouds, and then those clouds become supersaturated and precipitation occurs. Now, some precipitation will go right back out into the ocean as it falls in the ocean, but some of it's going to land on the Earth's surface, on the land itself. So when water hits the land, it really has two options. Some of it will spill off the land through surface bodies of water and go right back out to sea. Some of it will collect in lakes and ponds and other fresh bodies of water. But the other areas, if the soil is permeable, that means it's not made up of impermeable surfaces, or if it's not too steep and the ground isn't already saturated, that water will then move down through the soil and recharge groundwater supplies. So this is, of course, our hydrologic cycle, and we know this well, and that keeps this water moving. So even though we have a very little amount of fresh water available to us, it's continuously recharging and renewing itself. Like any renewable resource, though, we know if you overuse that resource unsustainably, perhaps by diverting too many rivers, withdrawing too much groundwater faster than it can be recharged, well, then you run the risk of running out of that fresh water. Moreover, we also know that if we start to pollute, both through point and non-point source pollutants, we can also overwhelm those freshwater systems and diminish our supplies. So that's it for our water resources. Next, we're going to examine in greater depth groundwater supplies. So stay tuned, and we'll see you soon.